Okay, the previous section we looked at identifying arguments and differentiating arguments from non-arguments. In this section and the sections to follow, we will begin to analyze arguments because not all arguments are created equal. Some arguments, as we will see, are better than other arguments. And also there are two distinctive styles of reasoning that we will begin with. The first is the inductive style of reasoning, which can be traced to people like David Hume, who argued very much for this kind of inductive approach to reasoning. And inductive reasoning generally goes from the particular to the general. Not always, but the key thing to differentiate induction from deduction is that the claims that are inductive are likely true, right? There's a probabilistic element to it. There isn't absolute certainty. There's a chance, maybe a remote chance, but there's a chance that the claim is wrong. Deduction, by contrast, arrives at premises or arrives at conclusions with certainty. So if the premises are true, then the conclusion is certainly true. Most philosophers, and this is what Hume was pointing to in one of his texts, ideally would prefer to have deductive reasoning in all of their claims because it gives us certainty, whereas induction only gives us likelihood. And for Hume, all knowledge we get from experience, and experience does not give us the future, so we can only guess the likelihood of what the future will be like. We can't know with certainty what the future will be like. So those are two different styles of reasoning, and there will be different forms associated with each of these two styles of reasoning. And so that's kind of what these next few sections are really focused on. So let's look at the deductive argument forms first. One common example of a deductive argument form is mathematics. And so the conclusions that follow from mathematics are taken to be true with certainty. There's no probabilistic element to it. It's not that they are likely true, they are definitely true. So you can't go up to your math professor, for instance, and say, "Are you sure this is right?" Right? In mathematics, there is certainty. Now, we won't be looking at mathematical arguments in this class, but if you were in mathematics or in higher level math, you'll notice that there are often mathematical proofs that are an important part of what mathematicians do. Another deductive argument form is argument from definition. So if you define something in a particular way, so we could say, for instance, that a bachelor is an unmarried man. So if you know that John is a bachelor, you'll know that John is an unmarried man. And how do you know that? By definition, right? That's the definition of a bachelor, to be an unmarried man. So that's also a deductive form. It's there by certainty. Another form of deductive argument, and something that we'll be looking at quite a bit in this class, is a hypothetical syllogism, a sort of if-then statement. If you study, you will pass. The modus ponens argument, which will be something we will look at later on, is an example of a type of hypothetical argument. So we can say, if you study, you will pass. If you pass, then you will graduate. And so we can say, if you study, then you will graduate. That's an example of a deductive conclusion. Then we have a disjunctive syllogism. Either you will pass or fail. If you didn't fail, then we can conclude that you passed. That's an example of deductive. It follows with certainty from the relation between the premises and the conclusion. Now let's go on to inductive argument forms. First, most common inductive form is a prediction. You make a prediction that I will be late for class today because I've always been late in the past. Or you make a prediction about who's going to win a particular game based upon performance in the past, and so on and so forth. So predictions are claims that may have reasons to support the prediction, but those reasons don't give us certainty. It gives us a likelihood of what conclusion we can expect. We also have the inductive argument forms of using knowledge from the past to make a claim about the future. This is very much in line with a prediction. It can be more general in various claims that we make about people being late or various other conclusions that we might draw. Argument from analogy. Very famous argument from analogy is the watchmaker argument for the existence of God, where God is taken to be a craftsman, or in the same sense that a watchmaker is a craftsman who can make something very, very complicated, where all the parts are interrelated and interlocked and depend upon one another in such a way that only someone with great intelligence and skill could make a watch. The argument is that the world is a very sophisticated, complicated interlocking of parts and mechanisms and relationships, and that only a very intelligent designer or creator could have put all this together. And so it's an argument by analogy because it's basically claiming there's a similarity between the watchmaker and God. Another form of argument is to use facts about one thing as evidence to support possible facts about another. That's a similar, so it's kind of like an argument by analogy. And it doesn't give us certainty, but it gives us likelihood. If it was true with one thing, it's likely true for something else, something similar to it. And then generalization. Okay, so generalization is where we use facts about a few things to make claims about a general category or type of thing. Okay, so to rehash or rehearse, not repeat what we've said here. So prediction. Prediction uses knowledge from the past to make a claim about the future. An argument from analogy uses facts about one thing as evidence to support possible facts about another similar thing. And generalization uses facts about a few things to make claims about a general category or type of thing. Okay. Continuing on, we have the argument from authority. Okay, an argument from authority is where a conclusion is taken to be true because it is asserted by someone thought to be expert or knowledgeable on a subject. So I'm a philosophy professor, have a dissertation and PhD in philosophy. So if I were to make a claim about philosophy or philosophers, you're likely to take what I say to be more likely true than what your hairdresser might say about philosophy. No offense to hairdressers, but they may not be an authority or expert on philosophy. They may be, you do not know, but it's more likely to be true when it's coming from someone in a position of authority. An argument based on signs. This is more an example of things like reading road signs. I was on a trip to Iceland last summer, and I went through a tunnel that could only fit cars one at a time. Right, it was not a 2-lane road tunnel, but cars could go both ways, both directions. So I was like, how is this going to work? Well, there was a sign before or next to the tunnel, and some of it was written in red with an exclamation point. So I inferred from that sign that this wasn't important, but it was in Icelandic, so I could not read it at all, and so I had no idea what it was saying. But I knew enough to know that what it was saying was important. It turned out that it was saying that you'd give right-of-way to the cars coming towards you from the other end of the tunnel. I couldn't read that, so I didn't know that that's what I was supposed to do. But I did know that that was the important point to gather, simply because I inferred it from the red. So that's an example of the sign. Red words on signs often are indicative of importance. So that's an example, not always, but that's an example of an inductive conclusion that one would come to. Causal inference is also an example of a conclusion that one comes to from an inductive conclusion. So, for instance, if a conclusion is drawn because of a presumed causal effect. For example, let's say I left a beer in the freezer overnight, then I can say, it's likely going to be frozen in the morning. How do I know that it's going to be frozen in the morning? Because of my inference based upon awareness of causal laws of being in a frozen temperature for a certain amount of time, it will end up being frozen by the end of the night, by morning. So these are some examples of inductive arguments. Now, not all arguments are valid arguments. And so the key point for a valid argument is that true premises always lead to true conclusions, or a true conclusion. You cannot have true premises lead you to a false conclusion. If you can get a false conclusion from true premises, then it's not a valid argument. So for instance, if you study, you will pass. Here's an example of a hypothetical syllogism. You studied, therefore you will pass. Okay? That's a valid form of argument, as we'll see later on. We'll see that as a modus ponens type of argument. But not all argument forms are valid. So for instance, here's an invalid form, where true premises may lead to a false conclusion. Okay? If you study, you will pass. That's true. We'll say that that's true. If you study, you will pass. And we'll also say it's true that you passed. Okay? Therefore, you studied. Okay? That conclusion that you studied is not necessarily true. Right? The test may have been extremely easy, and you passed it without studying. And so that's an example of what we will see later on as the fallacy of affirming the consequent. But it's an invalid form. So the point here, getting back to what I said about logic in the previous section, is that logic analyzes the relationships between premises and the conclusion, or the formal relationships between premises and conclusions. It does not look at, it does not set out to prove the truth of the particular claims. That's the task of science and our everyday world experience. It sets out to look at the logical relations between premises and conclusions, or the form. And so invalid arguments are invalid primarily because of their form. Now, content sometimes will come in, especially with inductive arguments, as we will see, but for the most part, what we will be dealing with in this class is the logical form of relations between premises and their conclusion. Okay, so now let's go on and look at relationship between sound and unsound arguments. Okay, now, first off, a sound deductive argument is valid and has all true premises, and an unsound deductive argument is invalid. It has one or more false premises or both. Okay, so in the exercises, you'll be asked whether a deductive argument is sound or unsound. And a sound deductive argument is always going to be valid, right? Because it's going to have true premises. And if it's a valid argument, its true premises will always lead to a true conclusion. Okay. Now, an unsound argument, there's two reasons or two ways for an argument to be unsound. One would be if it's invalid, or if one or more of the premises are false. Or it could be both. Okay. Those would be the reasons for an argument being unsound. Again, this is all in the text, so you can see that in the text as well. Okay, now onto inductive arguments. Not all inductive arguments are created equally. Some are stronger than others. Some are weak inductive arguments. So a strong inductive argument, it is improbable that the conclusion is false given that the premises are true. Okay, so given certain premises, if these premises are true, and it's unlikely that the conclusion is false, we could say that's a strong inductive argument. An underlying assumption here with respect to inductive arguments is that there's what's called a uniformity of nature. What is meant by that is that the future will continue to be much like the past, that things just don't change randomly, that there is a kind of continuity and of form, that things tend to happen in generally the same way in the present and future as they have in the past. So that's one of the basis for inductive arguments. And so if something has continuously and repeatedly happened in a particular way throughout the past as much as we know it, then it's a strong assumption or inference to make that the present and future will continue to be the same way. Now, of course, we can't say that with absolute certainty. That's one of the key points about inductive arguments. They don't give us certainty here. A weak inductive argument, it is possible that the conclusion is false given true premises. So it doesn't quite establish the connection between the premises and the conclusion in a strong way. Now, another distinction with respect to inductive arguments is that some are cogent or uncogent. A cogent inductive argument is they are strong and have all true premises. So the premises are true, and the likelihood of the conclusion being true is also very high. So those will be called cogent arguments. A cogent argument does not apply to deductive arguments, right? That's where they are sound or unsound, right? Cogent is something that applies to inductive arguments. An uncogent argument is an argument that is weak, right? In the same way that an unsound deductive argument can be unsound in two different ways, or both of those two different ways at once. The same is also true for an uncogent argument. They are weak, right? Meaning that they have not a very strong connection between the premises and the conclusion. The premises may not lead one to infer a high likelihood of the conclusion, or it may have one or more false premises. Or again, it could be a combination of both. Okay, so go through these sections, kind of study these relationships between deductive and inductive arguments, strong and weak, cogent and uncogent, and then you'll be able to do the exercises which will kind of reinforce some of these distinctions. Once you've understood the differences between deductive and inductive arguments and strong and weak, valid and invalid arguments, then we're going to move on to one of the key aspects of logic, one of the key tasks of what a logician does, and that is proving invalidity, right? Part of what logic helps you to do is to avoid making bad arguments, namely invalid arguments. And a few points here before I give you the exercises, that validity is determined by the form of argument. When we're talking about a deductive argument, that is. It's not the content. Remember, science is what gives us the truth or falsity of the content. It is the form of the argument that's crucial for an argument being valid or not. So one way to prove an argument is invalid is what is called the counterexample method. Now, the counterexample method is basically you take the premises from a given argument and replace it with new premises, both of which are true, but which leads to a false conclusion. Okay. In other words, remember the key point, and this is essential to remember this. Every valid argument, the conclusion necessarily follows from the premises. So if the premises are true, the conclusion necessarily follows. So an unsound deductive argument would be one where it's invalid, so you have a false conclusion derived from true premises, or an unsound deductive argument may be unsound because one of the premises is false. Okay, so one way of proving invalidity is to show how, in that argument form as offered, you can get a false conclusion from true premises. So if you take an example, and we have this example here in the fourth bullet point, since some employees are not social climbers and all vice presidents are employees, we may conclude that some vice presidents are not social climbers. Now, as you read through that passage, it might seem like that's an acceptable point that one's making, but it's actually an invalid claim. It's an invalid argument. And so how can we show that it's invalid? Well, the first thing we're doing, this is our first kind of move towards kind of logical symbolism, is we take the various statements and substitute a letter for those statements. So what we'll do here is we'll take, since some employees, we'll take employees as E, we'll take E for employees, and are not social climbers, we'll take S for social climbers. So some employees are not social climbers. Okay, so that's a kind of claim all by itself. Some employees are not social climbers. Okay. Let's say that's true. Some employees are not social climbers. So some E are not S. And all vice presidents are employees. So all V for vice presidents are E, employees. Okay, you have to make sure we use the same letter for each to symbolize the same statement. So E for employees in all instances where we are talking about employees. This / between some E are not S and the all V are E is the way that we differentiate premises from one another. And therefore, as we go on, we may conclude, there's a conclusion indicator, that some vice presidents are not social climbers. Therefore, some V are not S. Okay. So what we've done now is we have translated this sentence into a kind of logical symbolic form. And what we do then is we substitute for E, S, and V different terms. So we'll substitute for E, animals, and substitute for S, mammals, okay, and for V, dogs, okay. And the point here is for the counterexample method is to create premises that are true, but the conclusion is false. So with that substitution, and cats and dogs and things like this is often a common way to go. It's an easy way of seeing that it's obviously false. So we can say some animals are not mammals, which is true, right? Reptiles are animals, but they're not mammals. So that's a true statement. All dogs are animals. That's true. All dogs are animals. So we have two true premises. But then, using the substitution that we have, right? Therefore, some dogs are not mammals. That is obviously false, because all dogs are mammals. So what we have done then is we have, by substituting for the employees, vice presidents, and social climbers different terms, we have seen that we can get true premises leading to a false conclusion. And whenever we do that, we know that the argument is invalid. And this is another way of emphasizing the point again, that it's not the content of the argument that's important for logicians, it's the form of the argument. So I think you now know or have enough in order to go forth with the exercises. Here's the exercises again, and it's also listed at the course website on Moodle. When you're done with the exercises, then you can go to the exercises video, and I will go over some of the examples or some of the exercises that were not given at the back of the book. Good luck.